afternoon. I'm going to be presenting my session on transforming language understanding using generative AI. I'm sure you would have heard a lot about generative AI already, but this session is more inclined towards LU and like how essentially that has transformed. And towards the end, I'm going to show a demo of Microsoft Foundry, some bits around that. So hopefully you will be able to gather some insight on how you can use an enterprise tool as well to transform language understanding. Before I start, a quick introduction about myself. I'm Shubhangi. I'm a senior analyst at an insurance company, which is a FTSE 100 company in the UK. I'm also a Microsoft MVP. Previously, I worked for AI startups, and before that, I was working for Tata Group. So overall, I have 10 years of experience in this space. I'm a speaker. I generally support a lot of community sessions, community conferences, and large-scale conferences as well. I also manage Women in Data, which is a community of, I think, 900 we are now, I would say, where I support other women in tech. And yeah, that's all about me in a nutshell. So to start with, this is the agenda for the session today. I'm going to start with what generative AI is basically all about. Then we'll dive into a bit about prompts. Then I'll go from there into RAG and what essentially RAG is. Then the architecture of RAG. And then a little bit about fine-tuning, optimization, and then monitoring and evaluation. So before I start, how many people have already built an AI application? I believe all of you. Okay, some of you. Cool. And would you say you are an expert in prompt engineering? Okay, one person. All right. What about building RAG applications? Have you implemented RAG as a part? Okay, one. What about performance optimization? Cool. So tell me a little bit about what performance optimization have you done?
Okay, so for the performance optimization, it's using RAG architecture to ensure that documentation can be actually processed without human intervention. So the process has to do with employing different agents that read and scans organization documentation and also give an input or recommendation for improvement on what you're working on. So that's the project which I did, and that was done using the Azure agencies as well.
Okay, all right, cool.
Spot developer in the room.
Yeah. Someone's just showing off.
Cool. All right. So before I start, let's start from the beginning of the story. So natural language processing is not new. It's not something which came 3 years ago or 4 years ago, and it's something which came out of the ordinary. Natural language processing is actually pretty old. It's as old as 1950s. So Noam Chomsky wrote a book on syntactic structures, which is basically how rule-based natural language actually works. And in his book, he has mentioned about ways in which you can evaluate language or understand linguistics. Now, when his book was released, after that we saw a transformation. We saw a lot of statistical approaches or network architectures that came in, which is basically the era of 1980s, 2000, where there were recurrent neural networks, there were hidden Markov models, and LTSM, and all these things came basically in this era. Now, when we were done with using hidden Markov models or neural networks, then came 2000, where we were more inclined towards deep learning, which we were using until now. There was a huge rise in neural networks, and that's basically where 2000s or 2018 is the window essentially they came in. And then fast forward to today, obviously we all know there is a lot of different models. There is BERT, there is GPT, there is Claude, several versions of Claude, there is Llama, and so on. So it's not new. It has evolved from a syntactic based structures to something more powerful, and it has evolved from machines understanding and generating human language. The only thing which has not changed is we still are building applications which are not reliable. We're still building applications which are not passing AI governance, and they cannot be scaled. So all the rest of the things have changed. So to move forward, I think this session I prepared in the start of last year, but it has changed so much over the course of time that I had to change several things. So the landscape has changed a lot, and in actually many different ways. So these are some of the 6 ways in which I see the maximum changes happen. First is pre-trained models. So a couple of years back when I was working in this space, we used to create small supervised machine learning models. And they were basically trained in a set of data that we were provided. But now we don't need to do that. We have pre-trained models. If you perform fine-tuning or build RAG architectures, you probably will be able to do that. Second thing I would say is continuous learning, which is basically these models, they are trained to predict missing data, which is like what probably the next word is going to be. So you can complete all the phrases without needing additional or maybe limited information. The third, which I would say is probably the most important bit, is contextualization. And like this word, context engineering, was like, I would say, in boom back in 2024. I mean, it's still like older version, however, people haven't still got it right, which is quite funny. Word meanings that you have, like, it's not just about the two words sitting in a phrase, it's also about the meaning that you can derive from them. And then the fourth one is interpreting nuances. So different people speak different ways. They have different nuances, their idioms, there are things which people have in their languages. It can interpret those nuances quite a lot better than we had before. Fifth is again voice and speech recognition, which is like if you are doing speech to text conversion or you're working on that kind of technology, it's actually pretty powerful in that area. It can provide you speech to text transition from one language to another quite quickly. And then lastly, query interpretation. I think everyone has used a chatbot and we know how they were quite clunky. You will ask a couple of things and they will break in between and probably not able to answer the right question. So generative AI can handle those multi-part conversations in which, for example, if your user has multiple intent, they don't have one single intent, it's able to transform and break them down and decide what is this user actually wanting to, what's the real intent of this user. So this is how the landscape has changed. Now let's see a use case here. For example, we have these three statements, right? In natural language processing, there are three main things. So the first statement that you see is basically an optimized text, which means like you have provided enough information for the machine to interpret and generate an outcome. The second one is a sparse input, which is basically a single word, two-word, three-word text. Not enough information to essentially decide if I can make a judgment. And the last one is a descriptive input, in which if you see there are three intents. The user wants to know about it, they want to pay the tax, they also want the receipt. There is no one single way of dealing with it. Now normally if you will use this on a chatbot, it will probably not work at all. The later two will definitely not work. And when I saw this thing, when I saw this set of data, I thought, how different are these? The answers am I getting, are they relevant? And what is probably the user's intent essentially in this particular use case? So the important bit here is like, when you deal with a set of data, which is like massive, you get all sorts of information. I think 2.5 years ago, I worked on a speech to text transition project, and initially when it was in POC and it was being tested, we thought, people will give us this kind of input. In real world, they didn't. And they gave us several sparse input and these kind of inputs, and the application just in like testing itself was like, oh, I cannot deal with this anymore, kind of. And it was really funny because we wouldn't have expected to provide them instructions in the start that, can you provide a more descriptive statement? Can you give more information? But apparently it didn't. So now what happened when LLMs came, we trained the LLMs, we implemented the LLMs on the historical set of data, which essentially made sure that if somebody says tax, it provides a recommended system sort of to clarify, are they talking about council tax, housing tax, income tax, what kind of tax they're talking about. And for the third one, I would say it's about breaking down that complex query into multiple different parts. So this is one of the very common use case. I think it's a very common UK public sector use case you will see, where people, if they call the customer agent, they would ask these kind of questions, and they would probably see that a lot of people like tend to ask very short or very long answer questions instead of asking very succinct inputs. Now what happens also is like, when you give these kind of inputs, generally you will see language familiarity, which I think is a lot of discussion. I have seen a lot of people talking about generative AI generates pretty similar outcomes like answers, and because they're generally coherent, very grammatically correct, and probably relevant as well, and can deal with wide variety of queries. Then second is fine tuning. So if you're dealing with, let's say, one set of data, which means like if you are like, for example, wanting to create an application or an agent which just deals with council tax queries, housing queries, or for example queries related to a particular set of data, you can just fine tune it. I think a lot of times I've seen people tend to not understand why fine tuning is actually needed, because they have not understood what domain specific data really means. So it's quite important to understand that it has a specific use case. It's not supposed to be used at every single point in time. The third one is conversational flow, in which basically what happens is the model essentially remembers your past historical conversations. Now this is a very, I think if you're building an agent or any sort of application, if you don't have a conversational flow, it doesn't remember who you are because there is no memory. It doesn't remember your preferences or the questions you've asked or who you are in the first place. So for this to work, we need a larger memory, which could be a short-term or a long-term memory. And the last one is relevant responses. So hallucination was a big problem, which means like, if you retrieve outcomes and responses, they should directly address user need. I would not want to build an application which is going to be used by a 60-year-old person and then it gives the wrong outcome, because that is totally unreliable and should not really be in production in the first place. So building applications that can provide relevant, accurate and coherent responses is quite important to ensure that anyone who uses it, they actually get the right information. They're not getting some random made up links which can create some issues. So if in the grand scheme of things, if you think about how responses are treated, these are the 4 paradigms you would think about normally in terms of response generation. So, but that is what has happened so far. But the conversation has now moved. It's no longer about generative AI can write fluent text. It's more about reaching a frontier of reasoning, where the agents are being created, which are reasoning capable, they are agentic in nature, they have a larger memory, and they are multimodal, which means they don't just generate text, they can actually retrieve and get your data and act. And this is basically where it stands today, as of today, when we are talking about it. And the things that are ongoing in this area right now are these. The first one, as I said, is reasoning models, not just predictive ones, which means they are built around inference time reasoning, which means chain of thought prompting. Now, I think I have a question here. How many people have implemented chain of thought prompting? No one?
I think I've seen it.
Okay.
I've used it. If you want to create your own environment that has chain of thought prompting.
Okay. So the first one, basically the reasoning models, which basically now there's a lot of chain of thought prompting, which is like reinforcement based learning, that is based part of how you build generative AI system. Second thing is, obviously, this is what I'm sure everybody would have heard. It's I have seen 1,000 times today already on LinkedIn, which is agentic. So it's the language models, they are increasingly deployed as agents now. And people have defined them as autonomous system of who can plan, act, create, which they are partially right now, but there is still an element of human in the loop involved, because who is going to take accountability for its actions. And the third one is long context, as I said. So Claude, for example, has released multiple models in the past couple of months, which is Sonnet, Opus, obviously Fable was gone and then came back now. So basically, larger context window or context is basically simple language. It's your memory. It remembers who you are, what you previously asked. If you're building an application in which you want your user to stay with you for 45 minutes, you cannot go with a short-term memory because it will forget. So it's basically the number of tokens, number of things it can remember about you in a single conversation and beyond. And this is essentially where the understanding bit, that they understand us, changes. Now the fourth bit is hallucination. Now hallucination basically is, I think there was a lot of buzz in the start that they give wrong responses. So in this one, what has happened is people are trying to use better grounding techniques. Anyone who doesn't know grounding or knows grounding? You would know grounding at the back?
Yeah, but I have a question in terms of long context states.
Yep.
So when do you implement the timing limits you talked about? Is it when you're training the agent or when you're actually building the conversation? When is it implemented?
So basically, normally what would happen is you will have a standard memory type, right? That probably will start with, let's say you will take a STM memory and you will be I don't want to expand any further right now. And then when you start getting users to interact, you will normally see, if you are, I don't know, if you're building a voice agent, it will be pretty long, because from my experience, they keep on talking for an hour or two, and the short-term memory will collapse. So unless you have a time limit you have set already, where you are telling your user this window is only going to be available for next 5 minutes, in a normal chat system you have, that's the only point you can use STM, otherwise you can't. Simply because it will not remember, it will just restart every other time. So it's dependent on, firstly, what your application is gonna be, then second, it depends on if you're implementing a timer in your system, where it is prompting the user and telling them that I'm only gonna be available, or supporting your answers for this much minutes or time. Or the third case scenario would be where you have implemented both of them. But like I would say that don't go for both of them because it costs a lot to have that much amount of context. It's precious and it's finite. So always go for a larger section of memory or data if you can. Otherwise, it can be pretty complicated if you switch it later on. So think about like in the start, how do you want a user to interact with your system in the first place?
So this is implemented when training the agents.
This bit.
Yes, the long context.
Why would you implement it when training the agent?
I'm asking, when is it implemented?
When you are designing and building it.
Okay.
Yeah, not when you are training
Okay.
it. Okay, alright. We were back on hallucinations. So hallucinations we haven't gone entirely, but they have reduced. And the most approaches people right now are using are grounding or self-verification or reinforcement learning, as I said in the start. This is basically when people provide feedback that the answer provided is not right. So kind of like a feedback loop. And then lastly is architecture, which is how you design it, is basically also the thing. So, which means like if you're using real-time, wider context window and multi-turn language systems, they are more viable than using something which is not like, which doesn't offer all these things. So if you want to build something which can be scaled further, these three things should be considered like as like non-negotiables in a sense to make sure that it actually has a potential to scale further. Now from here, let's talk about things which are still important. I know like a lot of things I've covered so far are mostly around like things which are already ongoing. Firstly, I want to really emphasize that verification is still important against real sources. Because a lot of times when you use chain of thought prompting, it reduces that pressure that like you don't need it. But verification at every step when it generates outcome is still important to ensure that like your real sources that you are taking in your data are right. Then second is million token windows, they will degrade no matter how much you try if you like don't pick your context wisely, which means like if you have a larger set of data, make sure that you're using some technique like summarization or chunking to make sure that you're reducing the context every single time. The large language model does not need to know every single detail about you, they just need to know enough information to make a judgment about it. The third one is about agents. So now oversight on how they do and how they perform actually matters a lot more, which means like having accountability implemented in your system so that like if somebody is building an agent, they actually know that in which part of the process it has failed or it has not worked. And then lastly, taking some multi-step actions, basically making sure that whatever agents you are building, they are actually further reliable in the process. Now let's talk about prompts. So I know somebody said here that I think in the back that they are pro at it. However, the funny part is 2 weeks ago I was at a conference and I gave this, not this session, another session, and people were asking how do we write good prompts. And then I was like, okay, I should add this slide as well because I don't know if everyone has like done their due diligence. So there are only 2 slides, so it will not be too much. So prompts, which we have been talking about since last 3-4 years, is really important. And the simplest way to understand is like the quality and specificity of the prompt is really important in influencing outcome. Now this is an example when you are a user. You're not building this thing. You are a user, you just want to get data out of Claude, ChatGPT, etc. So if you write like this, it's not going to work. So you have to simply be more descriptive and be more specific in the way like your AI can actually understand, okay, this user wants me to give this information. So be very precise. If you want to use a role, for example, you are a data scientist, engineer, developer, solution architect, be specific, give your role so that it exactly knows who you are, what you are seeking. Okay, then 3 types of main prompting techniques are these. I know a lot of people have made a new set of techniques, but in summary there are only 3. First is zero shot, few shot and chain of thought. Zero shot prompting is simple. Like you just give a 1-line detailed statement about like what is your goal. If you are summarizing a document, if you are trying to create a feed, like if you are trying to generate slides, if you are trying to brainstorm ideas, whatever your goal is, be very specific. Few shot prompting is, for example, you're trying to translate something or convert something and it doesn't know. It doesn't know what you are seeking, so give an example so that it exactly knows what to take. And the last one is chain of thought, which is actually used a lot more in building, in which you encourage step-by-step reasoning. So this is like a very simple speed and time prompt. For example, if I'm trying to solve a math problem, I would give probably something like that. But you have to be very specific in terms of how you actually give chain of thought prompting because it implements or encourages reasoning. So once you have implemented prompting, if you haven't also, like after this also, if you are not able to do it, you can use this one. So Anthropic has published this, which is a thought platform documentation. So you can find the entire overview of prompting techniques here, and then it also provides you prompt generator and some best practices here which you can look at. And it's quite useful if somebody wants to refine their prompts without much hassle. And if you haven't built a standard prompt yet, it also gives you success criteria if you want to learn how to build it. So this is one of the examples you can use as well if you don't have anything. So now let's talk about context. So which is I would say another very, very important part of building an application. So context only makes sense because it solves three problems. Problem number one, understanding. Number two, ambiguity. And number three is adaptability. So the first one, which is understanding, is essentially it remembers previous exchanges of conversation, which is standard, like it just remembers what we have talked about, what I want to ask, and it knows who the user is. Second is ambiguity. So when two statements are conflicting, right, it remembers which one to go for or which one to actually go with and adjust the responses accordingly. And the last one is adaptability, which is useful in dynamic environments because it wants to be flexible and responsive to the different users' needs. So for example, in the top right corner, I'll give an example. If I say, can you move it earlier? So in that conversation, it will remember I'm talking about a meeting. Otherwise, it will not. So that's why it's important to have context. And context is actually transformed into context engineering now. Initially, it was more about just giving description. So context engineering is basically about building dynamic systems that provide the right information to LLM. So essentially, they guide the behavior. So for example, your application contains the RAG, prompt, structure, outputs, memory, and it has a state. Everything around that is context. It's just like it's the system around it. And a lot of people actually think that LLM failures, they happen due to the model flaws. Actually, they happen a lot more time because of the missing context than actually the model flaws. And to retain that context, you need memory. As I said, you need either short-term memory or a long-term memory. Short-term memory keeps track of your ongoing conversations, session-based. For example, you are in a session for 15-20 minutes, it will remember that. Long-term memory is more about it stores your knowledge, your preferences, who you are, if you have multi-agent architecture, it will also remember that bit. So in scalable applications, I would say use long-term memory, but if you're building small personal scale application, you can go for short-term. And as I said in the start, without memory, it resets every time and it doesn't remember who you are or it will not be personalized at all. So now I'm going to give some examples and then I'm going to show some demos on Foundry. So I think I'll pick one by one. So for example, when we talk about enhanced capabilities, right? So I worked on several projects and I had to do the first one, sentiment analysis as a data scientist, and there was a big issue with us because what happens is we would see a word which is positive but it's actually in a negative context, it's giving positive sentiment. It's a big problem because it's not right. And for example, when I talk about semantic searches, right, it will do keyword searches and it will not try to find relationship between those words. And then when we talk about summarization, which is I have 3-4 page worth of data or context available, but I want to create a small summary. And the last one, text generation, which is basically just creating data. But with generative AI, you can obviously do all of that. And it's pretty interesting as well. So let's see some examples. So for example, this, if you see on my screen, is Microsoft Foundry. And
Yeah. Ignore them.
okay. Okay, alright. So this is, if you see my screen, it's Microsoft Foundry. And on the screen, there are a bunch of models, right? So you can actually quite a few models. And if you see, these are divided into model leaderboards, which means they tell you by default which are the best ones. And if you click on this one, it will give you more details further. It will give you details around, it will give you quality index according to it. Basically Foundry right now 5.5 is best. And you can see on the bottom, you can see highlights as well. Essentially, which are the top 5 and what is the success rate of each of them, what is the benchmarking rate and throughput rate. So here, each of these are AI system design metric, which means like if you're building a scalable good system, you need to know that how good the throughput is going to be, or how safe it's gonna be, can it handle the edge cases or not, and so on. So this is basically a good understanding in summary of like what different models do we have, which one you can use. And you can also evaluate this on your data. If you have a small set of data, you can evaluate that as well. Right? I think there's one more thing I want to show here. So on the bottom here, there is a trade-off chart, which I personally find really cool, because in this one you can see trade-offs between two things. So if I want to prioritize quality for my application, but I like probably benchmarking cost I don't want to prioritize, I can see what trade-off I'm making with that. So you can select the models here. For example, you can also add multiple different models. It will update accordingly. And you can also check quality versus safety or throughput, which are probably the key metrics as well. And towards, like, if you go downwards as well, you will be able to see things like which model has a better attack success rate, for example, and which you should use if your application is really like has certain cases, which could be edge cases, or it could have a contextually harmful behavior, or probably you are dealing with, for example, legal data, or your insurance, for example, dealing with some sort of like regulated data. So what domains or which models are going to be best for you? You can pick that from here. This model catalog which basically gives you entire, you can see there are like almost 182 models now. I think Grok 4 was released last month. I think it was in April back, which basically was released into Foundry, and I think there was this, I think Fable 5 was added last month, but I don't know, it hasn't worked for me since then, so it's a bit like in between. So this is basically the first bit, and if you go towards the playground area here, you can try a lot of things. So you get some free Azure credits, so you can basically use them for trying things out here. So let's try the language playground, since we are talking about linguistics. And in the language playground, you will be able to see quite a few things it currently does. Like there is sentiment, there is customer name, entity recognition, there is language detection, so a lot of things. So I'm just going to show some examples. Obviously, feel free to explore at your time, because I think we have 15 minutes left, so I want to just cover all the bits as well. So normally, when you will start, you will first have to create an API version for yourself, okay, and like whichever you want. I have built a couple of them, so I'm using the one that I currently have here, and you have to select what version of the model you can use. I would suggest just use this one. And if you have another language that you want to use, you can pick whichever languages you are wanting to pick from this. Like it doesn't just support English, it actually supports a lot more languages. Then towards the bottom you can see like you have other bits and pieces. Like for example, if you have some specific types you want to include, which is like standard values, for example passport numbers or tax filing numbers, you can mention that. So this is essentially like if you are trying to make sure that all these things are accounted for. So let's start with the first one. If I say here like, so now if I use my old approaches, which means like our data science approaches, probably the pretty word would here be in the positive sense. It checks line by line the sentiment of each one, which means like you will have a positive score for the bit, it has to be positive. You will probably see the negative score for the parts where you supposedly should be negative, and it gives you overall sentiment and statement-wise sentiment. This is good for people who are in customer-centric businesses, or for whom user behavior actually matters a lot more compared to like other people. It also provides you JSON, so if you want to like pick the JSON version of this data, you can get it from here. Again, like it supports quite a few languages. I normally use English. It also provides opinion mining if you need it. I tend to not use it because I only care about, like, I only need sentiment at the moment. So you can pick and choose things that you want from this one. Another interesting thing which I want to show you is
what's opinion mining?
so opinion mining is basically like, for example, if there's a huge amount of text here, like, and probably, for example, there is a feedback event. It will give you an opinion of like outcome, like for example, what do you in general think about it, like sort of like summary. So this is more numerical. That is more like contextual, like okay, this user probably does not like a product, something like that. So it's more like mining that text data to give outcomes, right? Another important thing I want to show is, which I think is super important, is PI extraction, because a lot of times when you deal with data, you can get things which should not really be passed on into LLMs or should be like stored very safely. It could be address, name, postcode, and so on. So in this one, normally what you would do is like, for example, I will give my input. My name is let's see. So this one, what it does really is like it will find, for example, what details are tagged as PII. So for example, my name is there, my postcode definitely will be classified into address, and on the right side it will give you details around like offset length and confidence score. I think somebody would wonder like, we are masking PII, then why it is showing, because we haven't turned on this option, so we should be masking PII here. And if you want to choose a reduction parameter, you can pick the reduction parameter from here. Essentially, you can pick anyone if you want, but I generally use asterisk, and I think most of the applications I've worked in the past, people use that. So now it could be case sensitive also, because sometimes the same data can also come in the case sensitive manner. So if your application requires that, please tick this box. So this is another interesting thing. Now these things, to use these things, as I said in the start again, you will need an API version and you will need an Azure resource setup before you actually implement that. So you need to set up that on your own, and these things will only work after that. The other thing which I find, which I also want to mention, which I think will be super important, is extracting named entities if needed. So for this one, like I would take like a legal NDA example, which is there, and in this one what it does is it will give you basically all the important phase entities that are available, like for example date, organization, who the person is, and like what kind of, for example, number do they have. Now this is super important in cases where like you want to collect some metadata and you want to know like what kind of information people are providing, and it, again, like it has more application, for example, in legal or insurance or sectors where like people might want to have or collect such information essentially. So make sure like you try these things before like implementing, and like understand like how you can use them. As I said, format and structure is pretty much same throughout. It's just the kind of data you can use.